the beginning of this is just a review from geometry. We have to, this is a skill y'all learned in geometry that we have to recall for this whole entire unit, okay? And it's simplifying a square root that can't be simplified, right? Like if you go to your calculator, let me make this smaller, and you type in square root of 24, it's going to give you a really long decimal. And we don't ever write that decimal, right? So instead, what we can do is simplify it. Y'all remember how to do that? It involves drawing a little tree. Remember that? So we're going to break up that number into all of its prime factors, okay? So you could break up 24 however you want. 8 times 3, 6 times 4, 12 times 2, however you want. But if you struggle with that, I would always say divide by the prime numbers first. So like, can you divide it by 2? Yes. So 24 is what times 2? 12, right? And then every time we get a prime number, we circle it. So 2 is a prime number. Prime means you can't break it up any further, okay? And then we go to 12, and then that's 6 times 2, right? 2 is a prime number, so we circle it. You keep going until you have all circled numbers. So 6 I can break up, right, into 3 times 2. And those are both prime, meaning we can't break them up. So once I have all prime numbers, I stop. And then, remember what you look for? We look for squares or pairs, okay? So you look for what pairs of numbers do I have? And it doesn't matter how you group them, but you see that you have one pair of 2's, right? This 3 and this 2, they don't have a pair. So for every pair that you have, you get to pull that number outside of the square root. Okay, so I have a pair of 2's, so I can pull out a 2, just one. So for every pair, you get to pull out one of those numbers. And then whatever didn't have a pair is stuck under the square root. So this 3 and this 2 did not have a pair, so they are stuck under the square root. And they are factors, they're multiples. You multiply them. So putting it all together, the square root of 24 is equal to 2 times the square root of 6. Because 3 times 2 is 6. That is the simplified radical form. Y'all remember that? You did it in geometry quite a bit. You actually did it with some crazy numbers. We won't really do it with that crazy numbers. All right, so let's try another one. So we've got the square root of 75. Okay? So we got to think, all right, obviously 75 is not a perfect square, right? We can check in our calculator, but we see, oh, it gives us a trash decimal, so it's not good. All right, so let's break that up. What times what makes 75? 5 times 15. Okay, 5 times 15. You could also do 25 and 3. Okay, so we got 5 and 15. 5 is prime, you can't break that up any further, so you circle it. 15 can be broken up, right? 3 and 5. Doesn't matter the order I write these, right? That doesn't matter. So I've got a 5, and a 3, right? All right, now I look for a pair. I have a pair of 5's, so I get to pull out 1 5 outside of the square root, right? So 1 5 goes outside of the square root. And inside the square root goes 3. So this would be 5 square root of 3. Okay? Let's do one more. So the square root of 48. Obviously, square root of 48 is not nice. If that were a 49, it would be 7 and it would be great. Right? But it's not. It's 48. Okay, so how can I break up 48? I mean, what times what makes 48? 4 times 12. Okay, 4 times 12. Does not matter how you do it, and neither of those are prime, so we have to break up each one. So if I break up 4, that one's easy. That's 2 times 2, right? And 12, we could do 4 times 3. You could do 6 times 2, right? 3 is prime, so we can circle it. but 4 is not, right? We have to break 4 up again into 2 times 2. Prime, circle U, prime, circle U. Okay, then we look for pairs. So I have a pair of 2's and another pair of 2's, right? So when that happens, when you have more than one pair, you get to pull out a 2 for each group. So I get to pull out 1, 2 for the first pair. I get to pull out another 2 for the second pair, and I'm multiplying them, okay? And then what is stuck under my square root? The 3. And then I simplify it just a bit further. I can multiply those 2 2's that are outside, right, and make 4. So this would be 4 square roots of 3. So what you have to remember is that however many, like when you're putting numbers here, they're all multiplied. So you don't add the numbers, you're multiplying them. Okay? We good? Okay, because this is going to pop up inside of other problems. Okay, now we need to talk about the square root property. Okay? So before we talk about that, I just want to ask you this question. If I asked you, what's the square root of 9? What would you tell me? Square root of 9. 3, right? You said 3. And we know it's 3 because if I square the number 3, I get 9. The square root is just the backwards way of squaring something, right? Square root means what number squared gives you that number. Okay, but I'm going to tell you there's actually another answer to that question. There's another number that we can square and get 9. Anyone know what number that is? It's negative 3, right? If I square positive 3, I get 9. If I square negative 3, I get 9. So the answer to the square root of 9 actually has 2 answers. It's got the positive and negative square root. So it would be the positive and negative square root of 9, which is positive and negative 3. Okay, let me get rid of this for a second. Okay, so that's basically what the square root property says. It says that if you have an equation where x squared equals a number, then you have to understand that there's really 2 answers to that. There's a positive square root and a negative square root. Okay? So this method, or this property, only works when the equation can be written without a bx term. Okay, that's how you know you're going to use this method, when you don't have a bx term. And what do I mean by that again? I mean, if it looks like this, I can't use this method because I can't have this bx. Okay, so these are just other equations that we can solve, all right? So if I look at this basic example, this is one I can solve with the square root property because I don't have a bx term, okay? So if I want to get x by itself, I have to unsquare it, right? Well, unsquaring is just square root. So what we would do is we would say, okay, I'm going to take the square root of x squared, and that's going to cancel out my square, right? Then I go over here, and I have to do the same thing. But according to the square root property, I have to remember that I have to take both the positive and negative square root of 16. Okay? Because of the square root property. So what is the square root of 16? What number squared makes 16? 4. And so I'll have to say x is equal to, and you can write it like this, that's fine, plus and minus 4, that means 1 positive, 1 negative 4. Or you say x is equal to 4, x is equal to negative 4. So when you write your solution, you could either use plus or minus, or you would say, each one separated. And I will tell you, when you are writing them, like on a paper, like on a quiz or a test, you probably want to do the plus or minus because it's shorter, less writing. But when you're typing in answers, like in Desmos, like you'll do in a few minutes, it's going to ask you to separate those answers. So you're going to have to actually type the positive and then type the negative. Okay? Okay. Now, what questions can I answer before we go over steps where we have to do a little more than that? Any questions? Please ask if you got them. Yes, ma'am?
Would it matter who goes first, the minus or the plus?
Good question. It does not matter which goes first, the minus or the plus. I could have put -4 first or +1. That doesn't make a difference. Okay? Okay. So now we've got steps to solve an equation that can be solved with the square root property. Step 1, isolate the squared term. So whatever is being squared, you want to isolate that. And what I mean by squared is it's the thing that's being squared, right? Like that's what that means. Apply the SRP, the square root property, by taking the positive and negative square root. Step 3, solve each equation and simplify. Step 4, put answers in solution sets. Okay? And these are never that crazy, right? These are pretty short. Okay? So let's look at the first example, example 1. So you'll see that I have printed inside of your booklet. I have all the steps printed for you again, so you don't have to flip. Okay? Okay, example 1. So we want to isolate the squared term. So you got to make sure you know what that is, first of all. What is being squared? What's the squared term? Ooh, so it's either 2x squared or it's just x being squared. It's actually just the x that's being squared. If the 2 was also being squared, if the 2 was also being squared, it would look like this. Parentheses 2x squared. Right? You see the difference? So the 2 is actually not part of what's being squared. So when I isolate the squared term, I have to get rid of this 2. How am I going to get rid of that 2? Divide. Exactly. Don't subtract it because it's being multiplied. So we're going to divide by 2. Okay? So now I'm looking at x squared equals 48 divided by 2 is 24. So that's step 1. I isolated the squared term. Okay? Step 2, apply the square root property by taking the positive and negative square roots. So now, in order to get x by itself, I got to square root that to cancel out my squared, right? Okay, and then I come over here, and when I draw a square root for 24, I need to include the plus or minus. You need to include the plus or minus. That's how you know that you have technically 2 answers there, right? Alright, so then I asked my calculator, hey calculator, what's the square root of 24? And the calculator is going to spit out a trashy decimal. Do I write that decimal? No. No. So if I don't get a nice number, I have to simplify the square root. That's where that geometry stuff comes in handy. Okay? So to save us some time, we already did that in the very first example, right? What was that? 2 square root of 6? But I can't forget, it's plus or minus 2 square root of 6. Okay? Because remember, we have to have both answers. Okay? And so my x is isolated, so I don't need to do any more to solve. It's already solved. I just put my answer in the solution set. So I can either write plus or minus 2 square root of 6. Or, especially if I'm typing this in a computer, I would have to write each one. 2 square root of 6, negative 2 square root of 6. Okay? When you're writing it, it doesn't matter, but when you're typing it, you're probably going to have to separate those 2 answers. Okay? Let's check that. Any questions on this one? Oh, you know what's a good way to check? Like if you're not sure, did I simplify that correctly? What you can do is you can go to your calculator and you can type the simplified version, 2 square root 6, and see if it gives you the same trashy decimal. If it does, then you simplified it correctly. Okay? Alright. Next one. Alright, this one looks a little bit different. But steps are still the same. Okay? Step 1. Isolate your squared term. So you've got to understand what is being squared. Is it x? Is it 4? Or is it all of x minus 4?
X minus 4.
It's all of x minus 4. So this whole thing is what's being squared. So if if you like to highlight this whole thing. So it's isolated. I don't have to do anything else. Okay? I can go straight, straight into square root property. So I can undo the squared with a square root, but I have to remember over here, positive and negative. You cannot forget that. That's the whole purpose, is that we have a positive and a negative square root. Okay? All right, now what do I got? I got x minus 4 is equal to, and then we can ask our calculator, hey calculator, what's the square root of 25? Is it a trash decimal? No, it's a good number. It's 5. But it's not just 5. Yeah, it's positive and negative 5. So I have to solve two equations here. I have to solve x minus 4 equals positive 5, and I have to solve x minus 4 equals negative 5. Why do I have to do that? Because there's two answers to the square root of 25. It's positive 5 and negative 5. So I got to actually solve those out. Why do I have to do that? Because I don't have this x here. I have x minus 4. So to solve, we got to add 4, right? Oh, sorry, I got to write plus 4. 5 plus 4 is 9. And then we come over here and we add 4. Negative 5 plus 4 is negative 1, right? So here's our solutions. Our solutions are 9 and negative 1. Okay? So that one had an extra solving step, and let's think about why we had to do that. Because after I did my square root property, I still had some work to do to get x by itself. Remember, our goal is always get x by itself. Any questions about this one? Anybody at all? You good? Okay. All right, let's look at this one. This one's a little interesting. See what's different about it?
Yes, you can. You subtract 9.
It has a bx. And we said, well, we can't do this if it has a bx term. Right, we can't. We can't use this method at least if there's a bx term. However, do you notice anything special about this trinomial? Ignore the 12 for a second.
Oh, it can all be squared by 3.
Yeah, this can be rewritten as something squared. Right? If you try to factor just this, factors of 9 that add to 6, isn't this just x plus 3 squared? Remember our completing the square days? That's coming back tomorrow. So yeah, the bx term, but this is what we call a perfect square trinomial. Now, if it was just any old bx term, then yeah, I couldn't do this. So x plus 3 squared equals 12. Now we can do this with the square root property, right? We don't have a bx term anymore. We can square root this, plus or minus square root of 12. So now I have x plus 3 equals plus or minus square root of 12. I don't need to ask the calculator, is 12 going to work out? Is it going to be a perfect square? No. So we got to simplify it. So I can do that off to the side. All right. 12. That's not too bad. 6 and 2. 2 is prime. 3 and 2. I got one pair of 2's. So I can pull out the 2 in front of the square root, and stuck under the square root is a 3. So this is going to be x plus 3 equals 2 square root. I'm sorry, what am I forgetting? I'm forgetting my plus and minus. Can't forget that. Okay, are we done? Is x by itself?
No.
No. You got a question? What's your question?
So from the beginning, could I just square the whole scenario by 3 so that the x will play out by itself?
No, because it would work if there was a 3 in front of that x squared. Then you could divide it all by 3. But because there's no 3 in front of that x squared, you can't do that. But good eye for that. We got to get x by itself. I can't have this plus 3. We got a minus 3, right? Okay, well, here's the most important thing of the day right here. How in the world do you do a minus 3 from this? You can't. Don't try. You can't. You just write minus 3. Okay? You can't take away 3 from the 3 under the square root. You can't take away from the 2. You just leave it like that. So when you write your answer, you're going to have x equals, but technically you don't really write it after the square root. You really put it before the square root. So we're going to put the minus 3 first, and then plus or minus 2 root 3. Okay? That is the most important thing of the day. So if I've got something like this and I need to isolate my x, and I'm going to add or subtract, I can't do that with this. What I end up doing is taking whatever I'm adding or subtracting, putting it in front of my plus or minus. Okay? I'm just going to make one up real quick. What if I had this? X plus 5 equals 2 square root 7. I'm just making, or plus or minus, sorry. Let's just say I had that, right? I'm making it up. There's no problem like that. Just working and I get this. And then I got a minus 5. Can I take away 5 from this? No. So I'm going to say x equals negative 5 plus and minus 2 root 7. Okay? One more just for fun. If I have x minus 1 equals plus or minus 3 root 3. And I want to get x by itself. I'd be adding 1, right? Can I add 1 to this side? Nope. I just kind of put it off to the side and I say x equals 1, then plus or minus 3 root 3. Okay? Anybody not understand that? How we kind of do that? The couple of the terms? You know what? You can always check. You can plug it in your calculator to see if they equal each other. Okay? All right. 2 more. They go quick. All right? Let's think about this one. 3x squared minus 1 equals 14. Is there a bx term? Nope. No bx term. So we're good. We have to isolate the squared term. So we got to think, what is the squared term? What is being squared in this problem? Excuse me. Just x, not the 3. Right? Just the x. So we got to get rid of that 1 and that 3, and it matters what order, right? Totally matters. We have to undo the addition subtraction first. So we're going to add 1. So then we get 3x squared equals 14 plus 1. Nice little 15 there. Okay? All right, then we're going to divide by 3, right? So we divide by 3. We divide by 3. So we have x squared equals 15 divided by 3. Nice little 5. Right? All right, now we have our squared term isolated. Now we can apply the square root property. So we square the left side to get rid of the square. Positive and negative square root on this side. Okay. So then we wonder, all right, what's the square root of 5? It's going to be a bad decimal, right? So we might try to simplify it. If I try to simplify the square root of 5, the only way I can make 5 is 5 times 1. I don't have any pairs. So what does that mean? It's simplified. I can't simplify it anymore. It just is what it is. Okay? So this will be x is equal to plus or minus the square root of 5. So in our solution set, we would put negative square root 5 and positive square root 5 Or you could say plus or minus the square root of 5. Okay? And these are you're gonna find in this unit, most of our answers are gonna be irrational like that. Because these are all the ones that we could never factor, right? And we can solve them too. They're just not gonna have as pretty answers. Okay. Doesn't it look like example 5 is almost the same problem? You see the difference? There's a negative in front of the 3 on this one. So let's see why we have a little caution sign, why we have to be careful. So let's approach it the same way. We're going to add 1, and then we're going to have negative 3x squared equals 15. And then we divide by negative 3, right? So we have x squared equals 15 divided by negative 3. Negative 5, okay. Then we do our square root property. How to do the positive and negative square root. Say, okay, what is the square root of negative 5? Oh, I never did the square root of 5. So the square root of 5 is that 2.236 number. But the square root of negative 5, my calculator has a fit. It says error, non-real answer. Why is it telling me that?
It's not real.
Why is it not real?
Does it say so?
Because it says so. This is what the calculator says. Alright, so why is this non-real? No, what does the square root mean? It means what number squared makes negative 5. In other words, what number can I multiply by itself and get negative 5?
You can't do anything with it. It's not a whole number.
Okay, well let's take one that is a whole number. How about the square root of negative 9? What number can I square to get negative 9? What number squared makes negative 9? Well, but if I square the number negative 3, what do I get? I get a positive 9. Well, how about I square positive 3? I get a positive 9. So I'm never going to get a negative 9. Right? You can't take the square root of a negative number. Because there's no number you can multiply by itself to get a negative. You square a positive, you get a positive. You square a negative, you get a positive. Okay? So, but I don't want you to say no solution, because there actually is a solution. We just have to look in a different number system. And we'll do that on Thursday. Okay? So for this one, we would say no real solution. If there is a solution, it's just not in the real number system. We'll get to talk all about that on Thursday. Okay? Now I want to show you also graphically why. Alright? Y equals 3x squared minus 1. Okay? And now I'm going to do y equals 14. So this is example 4. Okay? Here's example 4. There's our negative square root of 5 and our positive square root of 5. Okay? Alright, now watch. I'm going to change this. Now I'm going to do example 5. So all I'm going to do is put a negative in front of that. Okay? Alright. Can you see why it's no solution? Oh, yeah. That parabola is never going to touch that line. You can see. So I'm going to tell you it does. We just have to go in a different number system. But we'll talk about that on Thursday. Okay? Alright. Y'all can put a little glue on the back of this and glue it in your notebook. And then you need your computer because you have a short Desmos assignment.